So we're going to add these two waveforms together. Now we know from our standard formula that the first number out front is the amplitude, and we know this here is our phase angle, so this is plus pi divided by 40, this one is pi divided by minus pi divided by 70. The frequency we find from this formula. So that's the standard formula, omega t, where t is your variable. So we're going to use this formula to find out what that frequency is. And that'll tell us a period, which is really useful information when you start plotting graphs and things, to know how long it is. Okay, it gives you an idea what things are going to look like. So we need to rearrange this, so therefore the frequency is 2 pi, no it's not, it is omega divided by 2 pi. So that's just that rearranged. And our omega is this value 10 pi. So we've got an omega that equals 10 pi. So therefore our frequency is going to be f will equal 10 pi divided by 2 pi. So the pi's cancel, and then it's just 10 divided by 2, so it's going to equal, so the frequency is going to equal 5 Hertz. Okay? And then from that, I can then find the period, how long it takes to do one complete cycle, and that's from this formula, 1 over f. So it's 1 over 5. Okay? Which is 0.2. Okay? Maybe see what I've done there. Happy with that?
Is that still hertz?
Yes.
0.2 hertz?
No, sorry, seconds. Seconds. How long it takes to do a complete cycle is in seconds. It's also part of the reason why we like working in radians, because everything you deal with it'll end up being the same. It'll end up being in seconds to do your time. So it's very handy to have all this in radians rather than degrees, which just would be a nightmare. Morning, Ben.
Sorry, Mike.
That's all my bits. That's how to solve all those parts. But it's also useful information for what we're going to do now as we head towards adding these two together. So what we're going to do is we're going to use the compound angle formula to expand those two out. So there's, I don't know if the camera catches this, but I didn't want to write them on the board because it takes up too much space, but they're there. But we've seen them before and we'll see them as we do it. So the compound angle, or the sum and difference rule, it's also known as. You find them, it's one of the first ones you spot on if you ever look at the list of trig identities, it's a common one. Okay, so we're going to use them to expand it, and then we're going to use that formula. Once we've got, we'll add the like terms together, we'll end up with a sine and a cosine function. And then we can add them together using this formula, where we get, it'll be using this one, I won't write the full thing out for space for now, but omega t plus and minus phase angle, which we find from our resultant amplitudes. I won't go into that now, we'll save that for when we get there.
Jimmy, you know we just got the 0.2, is that for the frequency?
That's for the period.
Period.
So it's doing 5 cycles in 1 second. So it's taking 0.2 of a second to do one of them. Okay, so we'll expand out y1 and y2 first using the compound angle formula. Okay, now you can just do it all in one line, but you might find it easier to do y1 and y2 and then bring them back together, just for the sake of space on your paper. This is quite a wide board and I can't fit them across, even with that stuff written there. But what I'll do is I'll do them separately. So y1, go with my notes. So y1 expanded is going to be, in fact I'll make it shorter by not writing all this in. So I've got y1 If I expand it out, I will get this. I need to put the 4.67 outside in brackets and then work inside the bracket with the rest of it with the compound angle formula. So that will be sine 10 pi t times cosine of the b term, which is that one. So this is A, this is B for my compound angle formulas. So expanding them out, I've got a plus in the middle, so this will be added together with the opposite way around, which is cosine 10 pi t times sine pi divided by 40. Okay? So that's why you want to expand it out, firstly, first step.
Cosine 10 pt?
Pi t. 10 pi t. Same as this, it's this part of A. I know my handwriting's not the best. The trouble is you can't write too big when you've got a lot of stuff to write on it.
Yeah.
You need bigger boards.
Did you say you'd missed something off of that?
No.
You'd skipped something.
No. What I've done is, usually when I do these, I tend to do the whole left hand side equals right hand side. I tend to write out both sides on the board because I've got the space on the board, as long as I don't write too big. But when you do it on a piece of A4, it's not that wide, unless you turn it sideways. So what I've done is I've expanded out y1 first. When I've solved this one, we've got it down to its final components of a sine and a cosine. I'll then expand y2 and bring them back together. We're probably going to run out of space on the board, but we'll get there. Okay? So what I can do now to simplify this or to work through it is, I can't do anything with this, and I can't do anything with this, but I can solve cosine pi divided by 40. That's going to be a number, and I put it in my calculator, it'll give me a number from that function. And those numbers are, so if I solve this one, I'm going to bring it to the front, so I will still have my 4.67 out front of the bracket, and then I will get, so this one, put into my calculator, gives me 0.997, if I do it to 3 decimal places, and then sine 10 pi t. So I've solved that by putting my calculator and brought it to the front, because that's standard procedure to put the numbers out front. It becomes an amplitude, doesn't it, really? And then I've got my plus, and then I do the same on this part, and that gives me 0.078, and that's cosine.
What have you just solved there?
1 second. So what I've done is I've put sine pi by 40 into my calculator, basically.
0.078.
That's it, yeah. And then I can multiply out my brackets with that 4.67 into there, which gives me finally 4.656 sine 10 pi t plus, and this one will be 0.366 cosine 10 pi t. So I've gone as far as I can go with that now. Can't do much more. I can't do anything more. I'm now going to expand the same way y2. So I'll do this a little bit quicker. So y2 is going to equal, so expanding that out, I've got the 1.34 outside, and then if I expand it, I will get sine 10 pi t. This frequency is always the same. Cosine, the b term this time is pi divided by 70. And this time we've got a minus sign, so I'm going to use a minus sign here. And then the second bit is cosine, so the other way around, 10 pi t times sine pi divided by 70. Close bracket. And like last time, I can put this into my calculator and get a number. I can put this into my calculator and get a number, bring them to the front, etc. So I get 1.34 and I get 0.999. So practically 1. It wouldn't hurt if you treated it as 1, to be honest. In fact, I seem to remember when I put that in my calculator, it was fairly near 1. I think it keeps going for a few more 9s. Sine 10 pi t. Okay, and then this one, so minus, this one was 0.045 cos 10 pi t. And then when I multiply out the brackets, I then will get finally 1.34 sine 10 pi t minus, this is 0.06 cosine 10 pi t. Okay? So I've got, that's y1 and that's y2. When I expand them out and simplify them, I need to add them together, so that's what I'm literally going to do, y1 plus y2. So what I will do, to add them together, because I'm running a space, I don't want to write all this down and this down. So what I'll do is I'll just do a bit of manipulation. So what I mean by that is I'm going to add the sine functions together, and I'm going to add the cosine functions together. When I add that y1 and y2. Is that clear, or do I need to put another line in to show before I add them together, sort of thing? I'm adding y1 and y2, so that will mean that I'll add that sine function together with that sine function, adding the like terms, and I'll add this cosine function with this cosine function. Obviously that's a minus sign, so it end up being a subtract. So does that make sense?
Yeah.
I've got 4 points. So y1 plus y2 is going to be 4.656 sine 10 pi t plus this one 1.34 sine 10 pi t, and then I will have this, so it's plus that final one, yeah, 0.366 cosine, same frequency, minus, so I'm adding a negative, 0.06 cosine 10 pi t. Okay?
Let's write that down.
Yeah. So if I add them together, the results I get finally is 5.995 sine 10 pi t. And this is a plus term. Bear in mind it is plus because that's a good deal smaller than that. When you do your example, this might actually make this into a minus. If that number there is bigger than this, you end up with a negative answer. It makes no difference to anything. It makes a lot of difference to your phase angle and amplitude, but it makes no difference to the mass. So I've ended up with a plus in my situation. 0.3, is it? Wrong number, that one, is it? No, that's correct. 306 cosine 10 pi t. Okay, so that's my final answer of all this stuff, y1 and y2 added together. So now what we're going to do is we're going to use this formula to find out what they are when they're added together. This formula says this, if I write it all in, a sine omega t plus b omega t equals that. So what that's saying is, if I add them together, if they're the same frequency,
Okay, I'm also writing the formula, isn't it?
right, okay. A little bit missing from this formula yet, and that's this, that R is found from square roots of A squared plus B squared. So Pythagoras' theorem basically will tell us what the amplitude of the new waveform is. So it's nice and easy that. And then the phase angle is found from the inverse of tan of B divided by A. So again, it's easy. So what that will do, it'll take these two formulas, a sine and a cosine wave with the same frequency, but different amplitudes, obviously 90 degrees phase for cosine, add them together according to this formula. So that will give me, that'll give me R, and that will give me the phase angle, which might be a negative answer, so watch out for that. And that's nice and easy. Just number crunching, reach for your calculator. So I'll do it down here, let's do it in a different colour. So R equals, so it's that squared plus that squared, square rooted. So 5.995 squared plus 0.306. Okay? If one of these was negative, watch out for this, trips up a lot of people with Casios. If this was minus, don't put it in here as a negative, whatever you do. Because your Casio got the square. When you put a square in your Casio, you're probably aware of this by now, it actually gives you a negative answer. You've got to put it in brackets and then square it for it to work. It's to do with its BOD-mass function. There for good reasons, but it causes problems.
So just ignore negative then, yeah?
Just if you ever square in a negative number, on any calculator, any situation, always leave it as positive anyway, because it will give you a positive answer. Negative times negative gives you a positive. So you know it's going to be a positive answer. Don't put it in your calculator and believe the answer straight off. But what it'll end up doing in your calculator, end up taking this squared away from this when it's supposed to be adding it. So you get the wrong answer.
So where you say put the brackets?
Don't bother with that.
Don't.
Just put a plus in.
Right.
Even if you've got a negative there, put a plus in. Now when we do the next bit, the inverse of tan, that's a different story. But let's, okay. So that gives an answer of, according to my notes, of 6.003. Okay, 6.003. So that's going to be my new amplitude of my new waveform. So the amplitudes, when you add the two waveforms together, the amplitudes are changed. And the phase angle is found from the inverse of tan, of B over there. So my B is this, and my A is this. And that looks like it'll give me a low number. I've got, remember this is in radians, okay? Calculated in radians. I'll just put that there as a big reminder. Okay, your calculator needs to be in radians when you're doing any trig functions. I should have said that earlier. Reminder there, all these calculator has to be in radians for doing that, solving them numbers. Otherwise it'll be wrong if it's in degrees. Okay, and that gives an answer of 0.051. Okay? So that means my new waveform is this. It's 6, so y1 plus y2 equals 6.003 sine 10th pi t, and it's a plus is this one. If you had a minus sign, that would be a minus in there, and you'd get a negative answer. That would mean your phase angle is, after the 0 point. We'll see that when we do the graph. If you plot the graph really quickly, mine's going to start like that, back here, because it's a plus, so it starts on the negative side of your 0, and if you get a negative it'll start there. Okay? Because it's late in time. Yeah. Okay with that? Just things to watch out for. So going back to this, so I've got a plus phase angle of 0.051. Okay. That's it done. And then what we're going to do in a few moments, I'll try and video it, we'll see what it looks like. So you've got to do this on Excel, add the waveforms together in Excel and see what result you get. And from that graph of Excel you're going to add them together. Okay, and see what you get. See your waveform, and then from that graph you'll actually work out your amplitude, which is easy, and then work out the phase angle, which is not as easy. It takes a bit of work, you'll see.
And will you video that?
Yeah, we'll have a video in that.